Hello, my name is Camilo Lagos, and I will be presenting our paper using reasons for non-compliances to assess project performance in the last planner system, developed together with Professor Luis Fernando Alarcón and undergraduate students Fabio Basoalto and Oscar del Rio. Traditional management is focused solely on the transformation view. Therefore, it has been criticized as result-oriented. Planning is viewed as a one-time event using methods such as the critical path method and creating fixed complex schedules with highly detailed programs and activities with extensive use of Slack in between activities. Also, they focus on following the critical route rather than understanding planning as a dynamic continuous event. Control is focused on the iron triangle, which measures cost, time, and scope, and they use methods such as the earned value method or EVM. They use aggregated indicators to measure results, and they compare plan to actual progress to determine these indicators. Problems are that deviations are only detected after the fact. The use of Slack can hide deviations, aggregated indicators can conceal variability, and therefore traditional methods can fail to detect and prevent early signs of deviation. Several contributions have been made to planning and control, especially understanding the causes of deviation, for example, by applying multiple analysis to detect factors that can cause deviation, analyzing cross-impact of multiple factors to determine their importance or relative importance, and also benchmarking metrics that combine multiple factors that can affect project performance, and so they can help determine which projects have a tendency to be more successful than others. Also, efforts have been made to improve detection and predictability, like for example, graphical approaches, probabilistic approaches to improve earned value method, and also multivariate models of project performance that combine several initial factors, progress factors, execution factors, and then project result metrics, and can help explain why projects have determined outcomes. On the other hand, the last planner system has been proposed as an alternative to traditional management, focusing on processes. For example, work preparation, work stabilization, and then short-term compliance. It proposes a systematical planning and control cycle where long, mid, and short-term scopes are weakly connected, and they use process-oriented metrics to measure work preparation, constraint management, compliance, variability, and schedule accomplishment. They also register and learn from recurrent problems using reasons for non-compliances or RNCs, and they use that information to establish corrective actions in hope of improving project performance. It has been used over 27 years in multiple countries, and its impacts have been well documented. There have been several research about quantitative impacts of the last planner system on project performance, productivity, and many other factors, and also how it can be combined with traditional methods such as earned value to improve control and planning abilities, and it has been used together in several projects. Relationships between last planner metrics and key performance indicators for project execution and project outcome have also been studied, together with the impact of several last planner practices on project performance. New metrics have been proposed to improve aligning long, mid, and short-term compliance, but there are still several limitations to the current research. First, most quantitative research has found partial implementations that focus mostly on short-term compliance. They have used small samples, and there's a need for more quantitative research using larger samples. The opportunities are also that information technology systems propose ways to capture more data and also improve standardization of data and implementations. There are new quantitative approaches and tools to study that data and perform better analysis. And also, explorative research has found that early assessment can be made using last planner metrics. Our aim and scope of research is focused on the fact that most current research is focused on high-rise building, and they have not used quantitative information regarding reasons for non-compliances. So there's an opportunity to assess their frequency and impact on projects with different outcomes. Therefore, we intend to assess what difference can be identified in projects with different schedule accomplishment by developing quantitative assessment metrics using reasons for non-compliances or RNCs, and then identify differences in projects that have successful or non-successful outcomes using that RNC information. Our scope is to use 23 complete Chilean industrial projects that use the same technological support system to implement the last planner system. And we will use standardized weekly information regarding their PPC, progress, constraints, and reasons for non-compliances. Also, we will classify projects into a success or failure group based on a clustering algorithm. Our methodology starts by reviewing literature with a special focus on quantitative research and the assessment of delay and deviation factors. Then we will collect information from the IT support system, perform project clustering using results information, construct RNC metrics by standardizing the types, origin, and sources of the reasons for non-compliances, using standard last planner indicators such as the percent plan complete or PPC to measure differences in project with different outcomes, and then comparing the traditional last planner metrics to the new proposed metrics that use RNC information to see if RNC information can be used to assess performance and classify projects as successful or not successful. As mentioned before, we will use 23 industrial construction projects that had implemented the same support system. And we collected data from over 700 weeks and over 400 reasons for non-compliances. We recovered last plan information, but also the results, which were the schedule performance index at the time of plant completion and the schedule deviation at project completion. RNC information was the percent of impact that each RNC caused on each commitment at a certain week. And also we standardized the type, source, and origin of the RNC information so that different projects could be compared. We use origin as internal or external, internal meaning that the problem can be controllable by the project team. The source was the contractor, the client, of third parties, like suppliers, for example, and 8 different types of reasons for non-compliances. And using that information, we developed our first indicator, which was RNC relevance, that measured the frequency of each category times its average impact on commitments. In order to classify projects, we used a clustering algorithm based on k-means, using the final schedule performance index and deviation from each project. And our algorithm minimized the distance from each project to its cluster and maximized the distance between clusters. The resulting metrics of the algorithm allowed us to detect 4 clusters, and we used the differences in the clusters in the middle to develop success rules. As shown in this figure, successful projects had a schedule performance index greater than 96% and a schedule deviation lower than 5%. We then use this classification to compare last planning metrics. So we had the average values for the successful group and the non-successful group, and we use the man-witness U test to test the relevance, statistical relevance of the differences, considering a confidence level of 95%. As shown in the table, we did not find differences in the PPC average or percent of constraints removed average between the two samples, but we did find a difference regarding the constraints of the two groups. In fact, it was found that successful projects manage twice as many constraints per task per week than projects that failed to achieve their expected outcomes. Also, we did not find differences in the total number of reasons for non-compliances. We then used standardized progress intervals to determine the evolution of the PPC between the two groups, and we found that there were no significant differences in the PPC at each interval, but when we accumulated values, we detected that successful projects achieved a higher PPC, especially over the second half of project execution, compared to traditional projects, to non-successful projects. But the differences were small, and given that our sample was also small, we could not find a statistical significant difference between the two groups. So we then analyzed the RNC information using a quantitative approach. As mentioned before, we established a weighted relevance that was the frequency of each RNC category times its average percent impact on commitments. We used that weighted relevance and compared it to the average relevance of the category groups, creating a quantitative relative importance index, or QRII. As shown in the figure in the table, we found that successful projects had less internal originated reasons for non-compliance compared to the non-successful group. And in fact, the internal causes were almost 60% higher in non-successful projects than in successful projects. But when we apply the quantitative relative importance index to the internal and external sources and divided the QRI of internal to the QRI of external sources, we found a significant difference between the two groups. In fact, this can be understood as that failure projects have 2.5 times more tendency to cause internal problems than successful projects. Then we applied the same method, but using the source information instead of origin. And we here compare the RNCs caused by the main contractor to the ones caused by the client or third parties. So first, there's a significant difference in the QRI of the main contractor and the client. And in fact, as we see here on the second row of the table, the QRI of the main contractor is significantly higher in failure group than in successful projects. And the opposite happens when analyzing the QRI of the client, meaning that successful projects are more affected by the client than by the main contractor, and it's the opposite in the failure group. And also there's no differences between the QRI of the reasons for non-compliances caused by third parties. After analyzing the differences, we created a ratio of the QRI between the main contractor to client, and we found that the QRI of the main contractor and client were very similar, but in the successful group, but extremely different in the failure group. And after dividing the two, we found that the failure group can have 4 times more impact being caused by the main contractor than the successful group, meaning that the main contractor has extreme impact on project performance, and especially in the failure group compared to the client. We then use this information to construct a correlation analysis, and we find two strong correlations and two moderate correlations. The strong correlations were that the projects that had a higher schedule deviation also have a greater number of internal reasons for non-compliances, and most of them being caused by the main contractor. In opposite, if a project has more internal reasons for non-compliances, or more of them being caused by the main contractor in proportion to the other parties, it was found that they will expect a lower schedule performance index at plant completion. So relationships are stronger using schedule deviation as a project success metric compared to the schedule performance index. And if a higher percent of reasons for non-compliances are originated from internal problems or controllable issues, a higher schedule deviation could be expected. So here's an example of the strongest correlation that we found, which was between the percent of the problems being caused by the main contractor and the percent of a schedule deviation. And as shown here in the figure, you can see that the expected schedule deviation is possibly correlated to the proportion of the problems being caused by the main contractor, and that approximately 50% of the schedule deviation is being explained by this relationship, and that if the proportion of the problems that are caused by the main contractors increase, also the expected deviation from the project will increase. So we can conclude that there are many correlations between to be found between the RNC metrics and project performance, and that the reasons for non-compliances can help to significantly differentiate successful and non-successful projects, especially when using quantitative information. Finally, that differences can be found using these RNC metrics and are significantly higher than other last parametrics such as the PPC. The limitations of our research is that we use a small sample composed of only 23 projects, that we focused only on industrial construction projects that use a single type of IT support system, and that we based our performance outcome results based only on schedule performance, and we did not incorporate other metrics such as cost or the resulting scope indicators. But we did find several opportunities. The most important are that last parametrics can be used to assess expected performance, and probably at early stages, and especially that RNC metrics can help to determine these differences more significantly than other traditional metrics. And also, we find the opportunity to use data science tools such as machine learning to develop success rules and further analyses. Finally, we state the relevant need for more quantitative research with larger project samples, and trying to determine more quantitative relationships between last planner implementation, last planner metrics, and project performance. Thank you very much for your time.